If you've been affected by the job market or unfavorable working conditions, chances are you're already looking for a roadmap to upskill in your area of knowledge or start your own business in order to gain personal financial freedom. If that's you, but all you do is browse the internet or go from one video to another to learn from individuals' experiences, it's time to change your attitude. Today we will use real-life data about the companies in various tech and non-tech markets to evaluate which businesses are doing better in terms of attracting funds and acquisition. And in doing so, we will build a repeatable RAG-based workflow with AI agents to not only gain insights for our own personal financial plans, but also to perform deeper market analysis for a complete solopreneurship actionable plan. Oh, and did I tell you that it will be with 100% free and local tools? This will be a step-by-step description of the tools and the processes to build this agentic workflow. And like always, I will leave a link to the process in the description box so you can follow it at your own pace. So here is the roadmap. First, we will create a virtual environment and use it to install the local version of Open Interpreter. If you haven't heard of Open Interpreter yet, it's an agentic system that you can run locally to interact with various generative models such as LLMs and parse external documents for all sorts of projects. You have the option of using this system either with Olama or the Open Interpreter's own free model, which I will get to soon. If you're not familiar with Olama or haven't installed it, I will leave a link to a video tutorial about it too. No agentic workflow is complete without a RAG to retrieve relevant information from external documents. For this, we will develop a prompt for the model to take a local dataset as the input and perform a detailed market analysis of the successful businesses based on the funding and industry sectors. We will refine this prompt as we proceed so we can perform additional tasks and get more accurate results based on the actual data. To make the results more visually and analytically meaningful, we will take another step to produce plots of the data and automatically save them to our folder, as well as a detailed predictive statistical modeling on the data to predict which businesses are more likely to attract funding and acquisition. For the next step, we will ask the agent to take these statistical results and produce a list of skills needed, along with the estimated timeline to acquire these skills on a realistic basis for a solopreneur. The solopreneurship journey will not be complete without a well-thought and actionable weekly plan based on that timeline. This will be our next move, but we will also go one step further to make the plan more detailed, to include a syllabus of subtopics for learning micro skills, which is honestly such a forgotten practice. Finally, we will ask the agent to save the plan together with the results and their interpretations in a PDF file directly in our folder, and we will do all of this in natural language. But before we start, I just wanted to show you the dataset we will be using today. This is a dataset about startup businesses in the US. It includes many detailed information about these companies, but the ones I'm more interested in are the company names, their category or industry sectors, their total received funding in US dollars, and whether they have been acquired or closed. I will include this dataset in the GitHub repo for today's session, but if you'd like to follow along with other similar datasets for your region, feel free to do so. So let's get started. The first step, or creating a virtual environment, is as easy as these two lines in your terminal, where you use a specific Python version and the name of the virtual environment, and then navigate to its bin and use the source file to activate it. Once activated, you should be able to see its name at the beginning of the command line. Now we are ready to install Open Interpreter to run our agentic system with our choice of LLMs either locally or via their GitHub interface. Stick around till the end and I will show you how to use this system without installing it too. For now, I use pip install once to install the main Open Interpreter and once for the local version in my virtual environment. To use the system via your terminal, you can simply type interpreter at the prompt. This will ask you for your OpenAI API key, as you can see. This allows you to use GPT-4o. There are a number of other models you can choose from this link. I am more interested in the local version, so I will run Open Interpreter --local, which prompts me to choose Ollama along with other options, including Llama-File and LM Studio. If you choose Ollama as the provider, you can only use the LLMs that you have already downloaded in your Ollama like this. To start getting to know the system, I choose Llama 3. Notice that it also asks you if you'd like to try Open Interpreter's own open source model called Model I, which is in the development stage. We will get back to it soon, but for now we can continue with Llama 3. I gave it a prompt I've already written to take that startup dataset as an external document and extract the columns of name, funding, category, and status for the top 20 companies based on their total funding. This will be the base prompt we will work on and develop today. I could continue with Llama 3, but I was really interested in trying their free model, so I switched to Model I. Please be aware that your session with this model will be used to further train their model, so only choose this if you don't mind. I proceeded with the same base prompt and just dragged and dropped the dataset file on the command line. Yep, it's as simple as that. The model seems to have followed my instructions pretty well so far by generating relevant code to sort the data. It also asked me if I'd like to run the code, and of course I wanted it, so it successfully ran the code and extracted the top 20 companies based on their status as either acquired or closed, as you can see here. The agent also went on to explain the process, which was a cool touch. It also showed that only 14 of those companies are acquired. Next, I prompted the model to write a technical report based on the previous findings to show which category of companies are more likely to get funded, and then from its own knowledge base provide a list of technical skills needed for those categories, plus an estimation of timeline to acquire those skills. As you can see, the report is quite detailed. It shows the top 5 funded industry categories in the dataset with their main startup names, and it concludes that companies in digital and technological spaces are more likely to get funded. It then proceeded to give an overall report of the skills needed for each category together with an approximate timeline. Even though I didn't ask for an action plan at this stage, to my surprise, the agent went ahead and produced one. From the options it gave me, I was more interested in the web development part, and from my limited experience in this area, I can say the action plan was pretty realistic and well organized. The model went further and produced a more detailed weekly plan for each module, which is another nice touch. Now, if like me you keep a copy of your analysis, you can prompt the model in natural language to save the top funded companies in a CSV file and export it to your folder. Here you can see it has actually exported the CSV file to my folder. Be aware that if you don't specify a path, it will only export your requested file to your virtual environment folder where you have installed the system. Just as a side note, I prompted the model for a personal productivity plan alongside the skills plan too, and it offered a decent weekly plan, which will help with keeping you on track throughout your solopreneurship journey. But the awesome part was its ability to produce a plot using your local data. Here you can see it's writing Python code with matplotlib to plot the top funded company categories, and it automatically opened the file on screen for me. But I had to refine the plot to include different colors I wanted it to include in the plot, together with the grid background and a map of categories for each color. Here you can see the end result after 2 or 3 runs. I think this is a decent plot that you can easily use for your posts or even a professional publication. Before we continue, I just wanted to share an interesting observation. Each time the agent wanted to use a package that I hadn't installed, it asked for my permission to install it via terminal. And each time its code ran into an error, the agent automatically started to interpret the error and try to fix it. I believe these additional helpful features in Open Interpreter can really tell them apart from other free AI agent systems. We reached the exciting part that I think you've been waiting for: performing statistical predictive modeling on the data to predict whether a company would be later acquired or closed based on its total funding. I explicitly asked it to perform logistic regression to save time. This run was a bit tricky for the model. It ran into multiple errors, but it automatically repeated the whole process by either fixing the errors or by trying out different code. As you can see on the screen, it followed the standard procedure of importing logistic regression modules from scikit-learn along with the classification report and confusion matrix. And then it started to sort the data based on the funding and status, mapped status to 0 and 1, scaled the funding data, split it to training and testing sets, trained the model, complete the prediction, and then report the model accuracy and other classification metrics, and exported it as a text file to my folder as you see. It shows because of the imbalanced data in the acquired versus closed categories, the model only reached around 60% predictive power. I must say that I'm quite impressed by the agent's final response and its attention to all my instructions. Just to get a sense of the reliability of the results and the model's coding consistency, I repeated the same prompt for predictive modeling the next day in a completely fresh session. And I can confirm that even though this time the agent used a slightly different coding process, the results have been the same, as you can see in this new session report. Feel free to repeat this step with a larger dataset for a comprehensive plan. If you remember at the beginning of the video, I also promised to show you a way to use this system without the need to install it. If you navigate to the Open Interpreter's GitHub repository as you see here and just press on the comma key on your keyboard, you will be automatically taken to this new page where you can create a code space. When this blue bar of the code space shows it is fully loaded, you will receive a cloud virtual machine environment pre-installed with Open Interpreter. You can interact with the terminal of this online VS Code interface, and the rest is exactly as you've seen in this tutorial. I believe it's really helpful to gain insight into real-world data instead of relying on anecdotal recommendations for any serious financial plan. Here's another Agentic RAG setup for processing financial data.